Assalamu alaikum everyone and welcome to my presentation on paging and memory management for my operating system course. Today we will explore the challenges and the solution needed and related to the storing and accessing data in the main memory. So let's dive in. First of all, paging and memory management. Paging introduces us the concept of efficient memory utilization. We will see how paging works, how it helps us optimize the memory and improve the performance overall. Now let's look at paging. Page and ing, of course. Page is a single page and ing means multiple pages stacked upon one another. Well, that's how the disk fragments or the partition blocks look like in the memory. Paging involves dividing the logical address space into fixed size blocks called pages. This allows for efficient memory utilization and helps us to retrieve data from the secondary memory. Now, to get into paging, we'll need to understand some basic concept first. So moving on to the next slide is about CPU and memory. We all know CPU is the control processing unit which controls all the processes in the memory. And now we are talking about the memory here now. So the memory should have three criteria to be good memory. First of all, memory size. Second, access time should be faster and cost should be lesser. These three criteria, fulfilling these three criteria are necessary for a good memory utilization. Now, moving on to understand the utilized memory, we will see RAM, random access memory. RAM is faster, but also limited in size, also costly. Storing all the data in the RAM, it's not helpful due to its high cost and a capacity constraint. Secondary memory is large, of course, but the access time gets lower because of its larger size. And because of this, none of these things, RAM or secondary memory, cannot fulfill all these criteria. But we should have a solution for this. Solution. We need a solution that balances all these three criteria. The larger size, fast access time, power and cost is less. Let's explore how memory management techniques addresses these challenges to fulfill these three criteria. CPU, main memory, and secondary memory. The necessary data first loaded into the main memory from the secondary memory or the secondary storage. Then the CPU fetches or gives request to the main memory. So we can see that CPU can get faster access through the main memory, also giving the necessary request to the memory from the secondary memory. We can utilize the secondary memory's advantage, number one, that is larger size, and utilizing the memory's faster access time, that is also a disadvantage. Now, three criteria also gets fulfilled and the overall system performance improves. Along with utilizing these 2 and 3, we can also reduce the cost of the memory. Now, we'll look into how secondary memory loads into main memory, how the processes are loads into the main memory. Now, next slide is about how processes are stored from secondary memory to the main memory. There are two types of allocation. First of all, contiguous allocation and non-contiguous allocation. Now, what is contiguous and non-contiguous? Contiguous allocation. Contiguous allocation allows the memory blocks allocated in contiguous manner, just like an array if we describe. However, because of this contiguous state, it suffers from external fragmentation. Means, let's look into the example. We can see there are 3 blocks, 4 KB, 2 KB or 2 kilobyte, and 4 kilobyte. Now, there is a process P1. It should have a allocation for 5 kilobyte. Now, we can see 2 KB is allocated by another process. It is marked in yellow. But there are 4 KB and 4 KB are remaining. So 5 KB should have been allocated, but it cannot get allocated because of it. The 4 KB and 4 KB are not contiguous. There is an obstacle of 2 KB. Because of this, it is suffering from external fragmentation. This is external fragmentation because required memory is present, but not in contiguous state, not in the neighboring state. There is obstacle. There are some processes allocated on the way of the memory. Now, this is solved by non-contiguous allocation, which is about linked allocation. Non-contiguous allocation linked the memory blocks, enabling easy access from one memory block to another. This helps overcome the challenges that we face in the contiguous allocation, that is external fragmentation. Memory blocks are linked from accessing from one to another becomes easier and faster. Now, we will see the non-contiguous allocations, one facility, that is paging. Paging is a part of non-contiguous allocation. Paging is a memory management scheme where the operating system retrieves data from the secondary storage and in fixed size block. It optimizes the memory usage and helps efficient data retrieval from the secondary storage to its scheme. Now, how it retrieves data, we'll see. First of all, we need to get introduced something called virtual memory. Paging is the idea of virtual memory. Virtual memory uses techniques like paging, allows the memory to be virtually increased. Let's say we have a RAM and we are using playing game, graphic design, and video editing. So what virtual memory does, it allocates a portion in the hard disk or in the secondary memory, named as virtual memory. So when I'm playing game, I am not editing, I am not graphic designing. So these two unused processes are allocated into the VRAM or the virtual RAM that is portioned onto the hard disk. So when I'm opening the process, editing or graphic design, these two are again rolled back to the main RAM memory or RAM for fast access. So this gives us an advantage that we can use the secondary memory storage larger size for accessing processes faster and more easier. This is how virtual memory works, and how these are partitioned into the hard disks is by pages. Now, moving on, this way main memory size is increased because of virtual RAM. So some portion of the virtual memory comes on the hard disks are required for storing the virtual RAM as pages. Now, we have learned every criteria that was needed. Now let's dive into the main paging. What is paging? How paging actually works? How paging divides the secondary storage's portion as virtual RAM. Paging. Now, paging is paging involves, as you all know, is retrievable data from secondary storage. Now, there are two things to be known: physical address space and logical address space. What is physical address space? Physical address space is the division of the main memory that is known as frames, whereas logical address space is the division of the second memory that is known as pages. That's what our main focus is. Pages means dividing the secondary memory in segments of blocks or fixed size blocks known as pages for data retrieval faster and loading up to the main memory. Now, how these are arranged, we'll look into that now. First of all, how paging works. We need to understand how CPU sends request that gets in paging later on. First of all, the logical address was generated by CPU. It sends a request to secondary storage. Now, what is it sending? It's sending PND. P means the page number, and D mean the instruction set. The logical address consists of page number and instruction offset. This helps us defining the what page number should we look for and what instruction should be executed. So CPU is sending this request in a block as logical address. Now, as you all know, what secondary memory does, it allocates pages from secondary memory. Pages from secondary memory are arranged as frames in the memory for faster computation, as we have learned earlier what pages and frames are. Now, there is another concept that you should know as page table. So when CPU is sending P and D, means page number and offset, instruction offset, the page table is unique. What it does is the page table unique to each process keeps tracks of where page numbers are stored in the memory. It plays a crucial role to finding and mapping the logical address that was sent by the CPU. Every process has independent page table for its own process and request. It tells where the frames or the pages are stored in the main memory. We can get the frame number by mapping the process request that was sent by CPU, then map again to the main memory frame number to get the page that you always wanted. Now, page table, how it works. Right now, we can see there is a request P and D that was sent by the CPU that gets allocated into the page table, and again you can get a frame number that get again allocates to the main memory, which is partitioned into size block known as frames. In this example, you can see the page table structure. The page table is updated dynamically as processes are executed. So main memory, the CPU is sending process and instruction offset into the page table that is get mapped by frames, and we are getting the frame number from the page table, and we are again sending a frame number in the instruction offset, which is the same as the one sent by the CPU to the frames that are in the main memory, and we are getting the P1 or P1, P2, which is the page number that you need always. Example of page table, how it is actually working, we'll see through the example. Let's say CPU is sending a page number 2 and the instruction offset of 15. Now, page table 2 is get access to the page table 2 is finding the frame number, mapping to the page number 2. Let's say the frame number is F3. Again, it goes to a block of physical address that is F and D. The F3 and instruction number, which is the same as sent by the CPU, is 15. Again, it is looking for the page number that is mapped by the F3 in the memory. We can see that it's finding F3 according to P2, means it is finding the page needed according to the frame. And what we are getting here is that the pages are loaded to the memory and mapped by frames, and accessing by page table, we are getting the desired memory faster and more easier. So this is an overview of how paging works. I hope after all this journey, you have understood how paging is and how paging is actually working and how it is helping us for an efficient memory utilization and improved performance overall. Thank you everyone, and thank you for joining. And this is the end of my presentation. I hope you will have a good day. Allah Hafiz.